All right, so today's video is 1.1 linear functions, and we have three objectives: to graph linear functions in slope-intercept form, to write slope-intercept form equations from a graph, and to convert other forms to slope-intercept form. Okay, you're probably noticing very quickly, slope-intercept form is our theme here. Okay, we're going to graph it, we're going to write it from a graph, and we're going to convert it from other forms. Now we have three, and this is kind of a warm-up segueing into that, right? We have a relation, we have functions, and we have linear functions. Now there's more types of functions than just a linear, but that's the one we're focusing on today. A relation is like this first graph that you see here, okay? There's not really this like nice pattern, or sometimes there could be a pattern, but the key detail here is if you look at the x value of 2 and you go up, there's two outputs for this, and that creates a problem, okay, in order for it to be a function. This disqualifies it from being a function, okay? And it's totally fine for a relation. We can have this scattered data, we can have these, points on top of each other for a relation. But once we get to a function, you can see they don't have that, all right? A single x is going to map to a single y, all right? And that's where we come up with that vertical line test, right? So if you can draw a line through your graph at any point and it crosses more than once, it's not a function, it's just a relation, okay? Now a function is a relationship where each input has a single output, and so you can see that there, right? If I draw vertical lines all the way through this, right, it only crosses a single time. Okay. And then we have a linear function, a function that has a set average rate of change that when graphed is a line, okay? Now, when we look at this graph, the most specific thing that makes this a linear function is its pattern here, right? We can see that in between the points, we have a slope of up 2 over 1. 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 It's consistent, okay? That pattern where your rate of change stays the same is what makes it a linear function. Now, within linear functions, we have many different types of forms. The most popular, I would say, is the slope-intercept form. And this y equals 3x plus 2 is a perfect example of a slope-intercept form equation. It is y equals mx plus b, okay? Now, the m is your slope. So I'll write that there, your slope. And that's your rate of change, right? That's how it changes. And your b is your y-intercept. And that's the number, the point, where your graph is going to cross the y-axis. So we've actually already been given a point, which is really nice here. That point is going to be 0, 2. All right, and you can see that 2 came from here. We know in order for it to be on the y-axis, x has to be 0 there. So we can assume that x is 0, and we get our first point. From there, you have a slope of 3, which is really 3 over 1. And the top number always stands for your change in y over the bottom number, which always stands for your change in x. So we're saying that we have a 3 change in y for every 1 change in x. Okay, now because this is a positive fraction, we're going up. So we go up 3 over 1. Okay, so you can see I'm filling in the graph now. I went up 3 spaces in the y, over 1 in the x. I'm going to do it again. Up 3 over 1. Okay, and I'm just going to draw my line, hopefully. Is that a line tool? Figure that one out later. Okay. Now the other one, very similar. We can see it off the bat. Y equals mx plus b. All right, we have an m of negative 3 over 2. We have a b of negative 1. So we have a starting point. We have a change. We start here at negative 1. And you can see because our slope is negative, our function is trending down and not up. So I'm going to go down 3 over 2. Down 3 over 2. Okay, now I always do it more than once just to kind of verify that pattern, all right? And the other thing you might be noticing about my graphs is they have no numbers on them. assume that we're going by 1 unless we state otherwise. This way, a single looking graph can scale if we have bigger numbers than 10, okay? Now, the next thing I'm going to want you to do, pause that video, and I want you to try now to graph this equation, to graph this slope-intercept form equation. Okay, concept 2. We're going to write slope-intercept form from a graph, okay? Now, when you look at this graph, or when you look at a slope-intercept form equation, we had two things, right? We had a y equals an mx plus b, but we only cared about the m and the b when we went to graph it. Well, it's the same thing here. We're going to extract that m and b data directly from the graph. So I'm going to find my points. I see a point here, crosses right over it. I see a point there. I see a point there. So I can pull that slope. I see it's going down 3 spaces. And it's going over 2 spaces, okay? So that must mean that my m is -3 over 2. And I can see it consistent, right? Down 3 over 2, okay? Now I go and I look at my y-intercept and I zoom in and, well, if this is a 1 and that's a 2, the other one's halfway through, we can say that's a 1.5. Now maybe it's a 1.49, right? But unless if it was a 1.49, you would have more information. It's going halfway through, it's a 1.5, okay? So that means my b is 1.5. And then I can just fill in the rest of the information. This is y equals -3 over 2x plus 1.5. Now, same thing for this other one, right? I have slope-intercept form. Y equals mx plus b. I need to pull the slope and the y-intercept from the graph. I go to my graph. I need to find I try to find 3 points just because then I know that I can see it consistently working more than once. And I just see, okay, it's down 2. So down 2, which because it's going down, it's negative. And only the y will be negative. And then over 3 to the right. And I see it again, down 2 over 3. So -2 over 3. And I see it crosses at 0. So that means my y-intercept is 0. So same thing, I have y equals -2 over 3x plus 0. Now you don't have to write the plus 0. You can just leave that off and you can just write y equals -2 over 3x. And as a general rule, if you see missing pieces of information like that, assume that that variable would be 0. Okay. Now the next thing I want you guys to do is here is another graph function. And I want you to try and write it in its slope-intercept form from the graph. Okay, here's our third and our final concept. I want you to be able to convert other forms to slope-intercept form. In my experience, I see students recognize and remember slope-intercept form over all the other forms. For instance, you probably forgot this one's standard. This one's point slope. And this one's just a non-form. Okay, it doesn't really actually have a form, it's just everything's kind of scattered. If you forget how to graph in those forms, you can convert all of these to slope-intercept form by solving for y. Okay, so I'm going to write it down here. I'm going to do each one right through. Okay, if I have 3x plus 2y equals 12, and I want to solve for y, that means I have to use that property of equality to undo everything being done to y to get it to the other side so that y is by itself. So I'm generally start away from y. So I'm not going to touch the 2. I'm going to move this 3x. It's a positive 3x, so I do the opposite to both sides. So I have minus 3x, cancels, and I get 2y equals 12 minus 3x. Now, I could have done negative 3x plus 12. It's the same thing, right? We can flip around over addition. But y is still not solved for at this point. Now I see 2 times y on the left, right? That's what this is. When you see a 2 and y next to each other, a -3 and an x next to each other, that's multiplication. So I have to undo multiplication by doing the opposite. The opposite of multiplication is division. And when you divide or multiply to both sides, you do it to every piece. When you add and subtract to both sides, you just do it once. So this cancels. 2 over 2 is 1. I'm left with y equals 12 divided by 2 is 6. And I'm just going to leave that fraction, negative 3 over 2x. Okay. Now this is flipped a little bit, right? We said y is equal to mx plus b. You can leave it as b and then mx. That's totally fine. If you want to flip it, you can say y is equal to negative 3 over 2x plus 6. Either of these are acceptable. Next one's point slope. It looks a little bit longer. Same exact principle. We need to solve for x. The only thing about this one is once you have x solved for, you need to make sure the other side is simplified. Because you can see there's only one thing on the side of x, this minus 8. I could easily just add the 8 to both sides, and now I have y equals 3 times x minus 2 plus 8, but that's not really slope-intercept form yet, right? We don't just see an mx plus b. Our slope would not be just a 3 there, right? We would need to multiply it in and figure out if it stays a 3 or if the number were to change. So we use that distributive property and multiply in, so we get y is equal to 3x and then minus 6 plus 8, and then we simplify, right? We have a negative 6 plus 8, so that's going to be 2, so y equals 3x plus 2. Now it's in slope-intercept form. Okay, our last one, this non-form over here, okay? The thing about this non-form is sometimes it's not a guarantee that it'll work out to a slope-intercept form. If it doesn't, then it doesn't. This one happens to, but you need to jump through some steps. You see multiple x's and you see multiple y's. We need to get those together. And you could start this so many different ways. You could take this at y and move it over here, or you could take this y and move it over here. You're going to see a lot of different ways, okay? So if you thought about doing this a different way than me, totally fine. So I'm going to rewrite it. And I'm just going to move my y's to the left and my x's to the right. So I'm going to minus 2y here and minus 2y here. And if you're really slick, then you can just do the other one in the same step. I'm going to move my x's at the same time. Minus 3x, minus 3x. And now I can go from left to right. Watch this. 3x minus 3x, 0. Gone. Right? I don't even need to write the 0. Y minus 2y, right? So that's a 1 minus a 2. So that becomes a negative y. Equals 2x minus 3x. So it becomes a negative x. This cancels. Plus 7. Now, most people would say this is in slope-intercept form. You see a y equals an mx plus b. But when you have a negative and a y like that, that's not solved for. So we know that technically there's a 1 in front of this y, right? Just like there's a 1 in front of that x. That's technically a negative 1x. We just don't write it. So it means I can divide by negative 1 to get rid of it. This cancels. We get y is equal to, and a negative over a negative, right? So if you divide a negative by a negative, you get a positive. So I'm just left with x. And then a positive 7 divided by a negative 1. Positive divided by negative gives us a negative. So we get minus 7. And so it turns out that is slope-intercept form. Now, a little trick when deciding on when to switch what, or which side to go to, you can see off the bat that when I moved my 2y over here, I set myself up to have a negative y. If I would have moved the y over to the other side, I would have gotten a 2y minus y, and it would have stayed positive. Might have simplified things in the long run, okay? All right, let's give you guys one to go over. All right, so you have 4x minus 3y equals 12. I want you to convert this to slope-intercept form. Okay, now here's actually, I totally forgot about this. We're gonna do a word problem, all right? And this is good, okay? You need to do word problems all the time, all right? No real life problem started out like this, right? A real life problem starts out like this, where you are given a lot of information. Sometimes you have to filter that information out, and it's not always clear what to do, okay? So let's dive into it. We have a young sumo wrestler decided to go on a special high protein diet to gain weight rapidly. He gained weight at a rate of 5.5 kilometers per month. Now I'm going to highlight that before I even go. A rate, which one's my highlight? There we go. A rate of 5.5 kilometers per month. All right. Now, if you remember back to that slope-intercept form, change in y over x, right? That's a 3 over 1. That's a 3 per 1. Okay. When you see things like per month, that's your rate of change off the bat. Okay. Now, after 11 months, he weighed 140 kilograms. Let W represent the sumo wrestler's weight in kilograms after T months. And then I want you to create an equation for the relationship between the weight and the numbers of the months. This can be a difficult problem because you don't have all the information yet to create an equation. If you look at this, we have 5.5 kilograms per month, and they want us to use T for months. So we know that 5.5 times however many months, right? But they already gave us 11 months. They said after 11 months, he weighed 140 pounds. Well, he didn't start at 0 pounds, right? He started at a weight that we didn't know, right? His initial weight, kind of like your initial value is the y-intercept. So we're going to go, and I'm just going to put a B there, okay? So that you can kind of think of that as a y-intercept. We don't know what he started at, but we know, and I'm going to take away this T for a second here. We're given 11 months, right? So 5.5 kilograms per 11 months plus his initial weight is supposed to give us 140 kilograms. Now remember, kilograms is nothing like pounds, right? So this weight is actually not a low weight. 140 kilograms is a lot of weight, okay? And if we can solve for B, we can actually set up our equation here, okay? So 5.5 times 11 gives us 55.5. Oh no. The math teacher is going to bust out a calculator because he had a long coronavirus summer. Nope, I was wrong. It's 60.5. All right. Plus B equals 140. All right. I subtract by 60.5 minus 60.5. And I'm going to get B is equal to 140 minus 60.5, which that one I can do in my head. That should bring us down to 79.5. Okay. Now we have that initial weight, but we don't have the actual equation for the relationship between the weight and the number of months. We need to plug that in. So we get W, which is a sumo wrestler's weight after T months, because now it's not 140 anymore. Now it's however many months. We want to know what would it be at 9? What would it be at 90? So W equals sorry, that was not very clear. 5.5 T plus 79.5. And now we have the equation, okay? Now that's a difficult problem, all right? And the reason why it's difficult is you have to go through extra steps to get your equation. But that's why this type of problem is so important. That's the kind of stuff that you see on the ACT where you have to jump through hoops to get to your final step. Now, I'm not always going to ask problems of this rigor, all right? And so I have one for you, all right? And I want you guys to try this one. It should not be as hard as the other one. You should have enough information in this one to go from the word problem to an equation, okay? And then it's going to also ask you to plug in to the equation, all right? Okay, so that's it. I want you guys to come prepared back to class with questions, okay? And that's all I got for you guys. I'll see you then.